This video is going to go over how to determine the end behavior of a polynomial. So first thing, we should talk about the shape of a polynomial. A polynomial either has an even degree or an odd degree. So an example of an even degree would be something like x to the fourth. And an example of an odd degree would be something like x to the fifth. So in each case, we have two options. For an even degree, our arrows or our end behavior is always going to be pointed in the same direction. If I have a positive leading coefficient, both are going to point up. If I have an even degree, but I have a negative leading coefficient, both arrows are going to point down. For an odd degree, it's always opposite. The arrows will point in opposite directions. If I have a positive leading coefficient, it's going to be opposite, but it's going to end up. If I have a negative leading coefficient, it's going to be opposite, but it's going to be down. So it starts up and ends pointing down. So these are the four general pictures you should always think of, and these are the four cases that you should consider. So let's take a look here. For each of the following, determine whether the polynomial is an even degree or an odd degree and the sign of the leading coefficient. So in this first example, the arrows point in the same direction. So the same direction tells me that I have an even degree. And because they are both pointing up, they're pointing towards positive infinity. So I have a positive leading coefficient. In the next example, my arrows are pointing in opposite directions. So because they're pointing in opposite directions, I know that I have an odd degree. And for odd, to determine the leading coefficient, I always want to look at the arrow on the right. So my arrow on the right points up towards positive infinity, so I have a positive leading coefficient. And then if we take a look at our bottom example here, they are both pointed in the same direction. So because they're in the same direction, I know that it's going to be an even degree. And they are both arrows are pointing down towards negative infinity. So I have a negative leading coefficient. Consider the following function. F of x equals 2x to the fourth plus x cubed minus x squared plus 5x plus 3. So I want to predict the end behavior. This is my end goal, part D. And this is usually what a question would look like. But A, B, and C are all things that you should be thinking in your head. So what's the degree? My largest exponent is my degree. So my degree is 4. 4 is an even number, so it's an even degree, which means they are both pointing in the same direction. So it's either going to be both up or both down. What's the sign of the leading coefficient? So if I look to the number in front, I have a 2. That 2 is a positive leading coefficient. So I know that they are both going to point up. So now I need to predict the end behavior. And what you see here is like a formula. As x goes to infinity, f of x goes to. And as x goes to negative infinity, f of x goes to. So I just want to sketch out a little coordinate graph. Remember that this is my x on the horizontal axis and my y is on the vertical. Positive infinity and negative infinity. Positive infinity and negative infinity. So this first piece, as x goes to infinity, this here is kind of like saying as x goes to the right, where I'm going to look at my right arrow. So if I look at that picture I circled up here, my right arrow is pointing up. And up points to positive infinity on the y-axis. And then what I have down here is as x goes to negative infinity. So x and negative infinity is on the left. So this is my left arrow. So now I want to see where is my left arrow pointing. My left arrow is also pointing up towards positive infinity again. So let's take a look at one example where these questions aren't scaffolded for you. Consider the following function. F of x equals 2x to the fifth minus x to the fourth minus 2x cubed plus 4x squared plus x plus 3. Predict its end behavior. So whenever I see this, I'm going to start by writing as x goes to infinity, f of x goes to, and that's what I'm going to fill in. And then my second line, as x goes to negative infinity, f of x goes to, and I'm leaving it blank again, that's what I'm going to fill in. So what I should be looking at, I have a degree 5. So my degree is 5, which means it's odd, which means it's opposite. So they're going to point in opposite directions. Now, I have a positive leading coefficient. So that means it's going to end up. So now I want to just sketch out a picture again. So I have my x and my y, my positive infinities, and my negative infinities. Remember, as x goes to infinity, this is going to be my right arrow. Okay, because this is the right side. So this is my right arrow. Go back to my sketch. My right arrow is pointing up towards positive infinity. So that's what gets filled in there. And now I have as x goes to negative infinity. So that's on the left. So this is my left arrow. My left arrow is pointing down. So it goes to negative infinity. So that's what gets filled in there. And this is my answer. Everything else is my scrap work. So that's how you predict end behavior. Odd is always opposite. Even is always the same. And based on their leading coefficients, you can figure out which way they're pointing.